Hey YouTube, how's it going? So today we are going to talk about zeros and ones. So whenever we discuss about zeros and one, generally it denotes something related with the computer. So you have already known that when something is zero, generally that is off, means off, and what is one, that is generally means on. But in your real life, you normally don't tell that, hey, zero the fan, or hey, one the light, like that. So whenever it is 0 and 1 discussion, you have to consider that it is related somehow with the computational things. So whenever we say that the computer, it only understands 0 and 1, what does it mean? If you have sliced the computer into half, what you will get? You will get some hard disks, you will get some RAMs. The hard disk may have some disk inside. The RAM will be there, you will get the motherboard and those kind of things. In case of your smartphone, you will find a single piece of hardware, that is the motherboard. Many of the transistors and the components are integrated inside the circuit. So if I say to you that, alright, let's slice your hard disk to half and then see, will you find any 0 and 1 inside there, sitting there? I mean, like this, beautifully 0, beautifully 1, shaping like that. Will you find that kind of thing in the hard disk? The answer is no. You're not going to find that kind of thing. Whenever you are downloading something, so if you see in the networking part where the cable inside your computer, punches in for you're having connection with the internet, if you look into this wire, what do you see? You will see some 0 and 1 flowing around. It's not like that. That's not, it is nothing like that. So what does 0 and 1 means? 0 and 1 can be measured by anything. It can be on, this is off, this is on. It can be a voltage, let's say 5 volt is 1, 0 volt is 0. It can be 3 voltage 1, 1 voltage is 0. It can be any of the state change. Like this state is right now A and this state is right now B, right? So this thing can happen. So on off can happen for any kind of electrical components like fan, light. In case of computer, it can be any transistor switching on and off. In case of 0 volt and 5 volt, any of the component, if its voltage when is measured in a specific interval of the time, so it can be denoted as 0 and 1. That 5 voltage is 1, 0 volt is 0. In similar fashion, in any of the other part of your computer component, if any of the voltages is 3 volt, any of the voltages is 1 volt, it can also be told as 0 and 1. So how these things are happening? So let's say, whenever you open your hard disk, there is a disk, right? And generally with that disk, there is a pin which has the ability to move around. This pin can move from here to here. And such kind of hard disks, maybe there can be a couple of hard disks like that in layers, okay? The bottom line is this thing can move around. Let's talk about for this disk only for the time being, okay? So these disks, we are talking only about the general hard disk. We are not talking about the SSDs. So let's consider that this disk has many of the rings like that, okay? So if you zoom out one ring, let's say we zoom out one ring like that, one track like that, and there are portions of the track where certain magnetic polarity can be changed, okay? How this magnetic polarity can be changed? If you flow a current through this pin, there are some mechanisms in this pin, and when this pin is actually on top of any of the polarity, what it can do, it can change the magnetic polarity of this strip. If it is like that, it can change it like this, okay? So the bottom line is, any of the state is getting changed by the current, okay? So the same thing can happen when it is not in the writing mode. This is in the reading mode, okay? So the reverse will happen. The pin will read this as this polarity, maybe as 1, and this polarity here maybe as 0, okay? So by this, 1s and 0s are denoted in the hard disk region by the magnetic polarity, which is stored inside. So whenever you switch off the computer, this thing remains intact and it's the same. When you boot up your computer, if you have seen already a movie, it always keeps like that, okay? It's like just a movie. So how does it take if we consider it about not only hard disk but all of the parts of the component? So let's say you are connected with your internet with this fiber cable. Okay. Now this fiber cable around here, this is a server. Let's say you want to download a movie. Okay. All right. And this is your laptop in here. In this your laptop, this fiber port actually connected here. Laptop doesn't have generally fiber port, but we are considering this part. Okay, let's forget it. Don't think it as a computer. Let's think it as a router. Okay, a router which is connected punched with this fiber cable. All right. So when you are actually downloading a movie, what is happening? This is a server, right? Now this server also has a hard disk. Inside this hard disk, it also has a disk, let's say. And here, some of the polarities are like that, some of the polarities are like that. Some are that, some are like that, some are that, some are like that. Alright. So this combination here in this hard disk actually denotes this movie. So when the computer reads this portion of the hard disk, it says, okay, your hard disk has one movie. Now, as a consumer, you are going to download this one, right? So whenever you are getting downloaded, this one also has a pin in here. And inside your laptop, you also have a hard disk like that. And you also have a pin in here. So when you say we are downloading, you actually are you downloading something? You are not downloading, you're actually copying, right? But the permission by which you are having the permission to move your pin in the certain manner so that you achieve this same state of hard disk plan, and at least in the region, in this fashion. So whenever you will pay for the movie or like any kind of monetary figure you are giving to that platform, so that platform's computer component is giving your computer the permission to move your disk in such a way that it creates this same amount of state in here, because you are not actually removing this thing or taking this full components from through this fiber pipe and into your laptop and into your hard disk like that. So you are just actually copying. So in that particular time, if this combination, let's say this is 0, 1, 0, 0, 1, 0, 1. Okay. So what you're going to do, you will create this same state in your hard disk so that it becomes like this. And when your computer OS operating software actually reads from this hard disk, it will denote inside it that, okay, this is 0, 1, 0, 0, 1, 0, 1. Alright. Now let's consider only one magnetic polarity we are going to write now. Okay, let's say this is you are going to write now in here. So what happens physically? This thing is now in read mode. So he read this part, like this part. The electrical pulse went back to this server. This server has an interface card which is connected with this fiber cable. Say for an example, there are lots of other components there. And this card is run by electricity, right? Okay. So in case of optical fibers, what happens is this thing are actually sensing light. So inside this transceiver there is a, let's say there is a bulb. If this bulb flicks, here this flicker will also happen because this is fiber cable, it's made by glass. And here there is a sensor inside this router also, which can sense this light, right? So let's say this is 1. For this one, in a certain fashion, this pin moved. This pin moved and converted this into electrical energy. For this electrical energy, this bulb flicked inside. This is a component, this is called transceiver, but let us call it as a bulb right now. So this bulb flicks once. So when it is flicked once, this full length of cable gets lighted up, and this sensor also gets the 1. Okay. So this is 1 in the case of magnetic state. This is 1 in case of an electrical pulse. Say there can be a current of 0.1 milliampere, or you can convert it as a voltage, that this is 1 millivolt, something like that, for an example. Okay. So whatever it is, the electricity is now being converted to something denoted as 1. Now this 1 milliampere or this 1 millivolt is not the same as this one, right? These are two different kind of state. This is a magnetic state, this is an electrical state, but both we are considering as 1 from our human understanding of knowledge. Okay. So this 1 is now passed through. If some guy actually could have seen in the cable, he would have said that that cable is lit up, right? He would just see that the cable is lit up. But if he was a computer back in its mind, he would have said, oh, this cable is in one position. Okay. So when this sensor got it, So this is also one for the sensor. But for the sensor, what is it? The sensor has the capability. There are lots of kind of diodes. There are diodes which emit lights, and there are diodes which can receive light and start the current. So it's not like that this will be always kind of like a diode. But for the analogy, just think it like that when light comes in, certain electrical flow changes in this path, and that is actually denoted as 1. So if you consider only this fiber part, this will be only light 1 and 0. So lights on and off. Maybe we can consider it as light intensity. We can measure only this cable part as luminescence. So maybe, let's say for an example, let's say 1 lumen, if there is 1 lumen inside the cable, so it will be considered as 1. If there is 0 lumen, technically it's off, so it will be 0, right? So here's another state, okay? So this came into here, this one lit up for the sensor. This sensor's luminescence went to the router and it again transferred into electricity, right? And this electricity passed down to this laptop, this hard disk. This pin again moved in that similar fashion how it moved, but now it is for the writing mode. It is not in the reading mode. And then it created this space inside your hard disk. And in similar fashion, all of the places will be created into your hard disk. And from the computer language, this figure will actually appear and your movie will be written in your system. And thus, like this way, this is the zeros and ones in your hard disk, in server hard disk. This is the zeros and one with respect of the transmitting part. This is the zeros and one with respect of the cable part. This is the zeros and one can be said with the respect of the sensitivity part, and back and forth. This thing goes happening all the way and again. So that is the case. That's why if we summarize, 0 and 1, it can be an on state, off state, could be inside a cable, which is not directly required for the computer to read when it is inside the middle of the passing. It can be a light, etc. It can be a voltage. It can be a 5 volt against 0 volt. It can be a 3 volt against 1 volt. Whatever level has been fixed inside the computer. So this can be a voltage. It can be a current, 1 milliampere, 0 milliampere, can be a current. It can be a measurement of the luminescence. Let's say 1 lumen, 0 lumen, 2 lumens, 1 lumens, whatever the level has been set inside the computer. Okay, so this can be the light sensitivity. So whatever is it, the way we denote in our human language, this will always be a human picture. This is a picture, just a simple picture. But the conversion which happens inside the computer, these are like that. So I believe this thing actually a little bit clarified that why we call it zeros and one, how this is actually transferred from one disk to another. Later we will discuss again for the understanding that how the computation is actually happening inside the computer. So how a computer works. Thank you for watching.